Here is the problem. Look at this chaos. We have hundreds of passengers, but there is only one security checkpoint open. Notice what's happening. People are stressed. The line is getting longer and longer. Some passengers might even miss their flights. This single checkpoint becomes what we call bottleneck. Everything has to squeeze through one narrow point. The checkpoint is overloaded. Passengers are frustrated, and the whole system is so inefficient. Sounds familiar? This is exactly what happens when a website goes down because too many people try to visit it at once. Remember when a popular concert tickets sale crashes the website? Same problem? Now let's say the airport management decides to open three checkpoints. Great idea, right? Well, not quite. Look what happens without proper load balancing. Gate A has 12 people waiting. It's completely overloaded. Gate B has only 2 people. It's mostly idle. And Gate C has 0 people. It's completely empty and wasted. This is terrible. We have 3 checkpoints, but we are still wasting resources. Gate A's staff is overwhelmed and stressed. Meanwhile, Gate B and C are sitting there doing almost nothing and getting paid to wait around. This is what happens to servers without load balancing. Some crash from too much traffic, while others sit idle. Uneven distribution equals wasted resources and unhappy customers. So, here's the solution: load balancing. A load balancer is a system that distributes incoming traffic. Think of our passengers across multiple servers, or in our case, security checkpoints. It ensures three critical things: speed, where fast processing because no single checkpoint is overwhelmed; balance, even distribution so every resource is used efficiently; and reliability, no single point of failure. If one checkpoint goes down, the others keep working. This is just not an airport theory. Right now, as we speak, load balancers are working behind the scenes here. Without load balancing, the modern internet simply wouldn't work. Let me show you how this works in action. Watch carefully. Here come six passengers arriving at the airport. Instead of them randomly choosing a checkpoint or all rushing to the gate A, they first go through our load balancer, that purple box in the middle. Think of it as an intelligent traffic detector. The load balancer says, you two go to gate A, you two go to gate B, and you two go to gate C. And just like that, perfect distribution. Every checkpoint has exactly two people, no overcrowding, no idle workers, and no wasted resources. So, this is a core concept. But here's where it gets really interesting. How does load balancer decide where to send each request? That's where algorithm comes in. There are actually six different algorithms, six different strategies that load balancer used to distribute traffic. Each one has its own strength and weakness. And tech companies choose different algorithm based on their specific needs. Let me go by one by one. First, round robin. Take turns, nice and fair. Second, least connection. Always pick the shortest queue. Third, least response time. Choose the fastest checkpoint. Fourth, IP hash. Same person, same checkpoint every time. Fifth, weighted round robin. Bigger checkpoints get more traffic. And sixth, random. Let the fate decide. By the end, you will understand the same algorithms that powers the biggest tech companies in the world. Ready? Let's start with the simplest one, round robin. Round robin is the simplest load balancing algorithm. It works exactly like dealing cards in a poker game. One for you, and one for you, and repeat. Watch the pattern. First passenger goes to the gate A. Second passenger goes to gate B. Third passenger goes to gate C, and fourth passenger back to gate A. And the cycle continues. A to B to C, and again A to B to C. The pros of the round robin algorithm is it's incredibly simple to implement. Fair distribution, everyone gets equal turns, no complex calculation needed. But the cons, here's the problem. It doesn't consider how busy each checkpoint is or how fast they work. What if gate A has the trainee who is really slow? It will keep sending people there anyway. Round robin works great when all your servers are identical and all requests take the same amount of time. But in the real world, that's rarely the case. That's why we need smarter algorithms. Let's dig into the least connection algorithm now. Now we are getting smarter. It's a dynamic algorithm that actually pays attention to what's happening. Look at our three checkpoints. Gate A has 6 people waiting, way too crowded. Gate B has only 2 people, much better. And Gate C has 4 people, middle ground. When a new passenger arrives, the load balancer asks, which checkpoint has the fewest people? The answer is Gate B with only 2 people, so that's where passenger goes. This makes perfect sense, right? Pros, dynamic and intelligent. It prevents any single server getting overloaded. Adjusts in real time to changing condition. And cons, of course, the load balancer needs to constantly track how many active connections each server has. That requires more processing power and memory. This algorithm is perfect for web applications where some users stay connected for a long time while others just load a quick page and leave. Let's take a look at the third algorithm. Least response time algorithm. This algorithm doesn't just look at the how many people are waiting, it also considers how fast each checkpoint processes passenger. Watch this calculation. Gate A, 3 people into 2 minutes each. That is 6 minutes total wait. Then Gate B, 2 people, 4 minutes each. That is 8 minutes total wait. And Gate C, 4 people, just 1 minute each. That is 4 minutes total wait. And Gate C has most people, but it's actually the fastest. Why? Because the staff is super efficient. They process each person in only 1 minute. The formula is queue length into processing speed. That's your total wait time. Our new passenger gets sent to gate C because even though the line looks long, the total wait time is shortest. The pros, optimizes for actual user experience, consider for queue size and the server performance. And cons, much more complex to implement, requires monitoring both active connections and response times. In the real world, this is what cloud services like AWS use. Some servers are faster than others, and this algorithm makes sure you get the quickest response possible. Now, here's something completely different. That is IP hash. Look at our 3 passengers. John has IP address of 192.168.1.5, which always goes to gate A. Sarah has IP address 192.168.1.8, always goes to gate B. And Mike has IP address 192.168.1.2, always goes to gate C. Every time John comes back to the airport, tomorrow, next week, next year, he will always go through gate A. How does this work? The load balancer uses a hash function, a mathematical formula that converts John's IP address into a number, then assigns him a specific checkpoint. The same IP always produces the same number. Pros, perfect for session persistence. Cons, it can create uneven distribution. What if your checkpoints aren't all the same size? Enter weighted round robin. Look at our 3 checkpoints. Gate A is large, handles 300 passengers per hour. Weight 3. Gate B is medium, handles 200 passengers per hour. Weight 2. And Gate C is small, handles 100 passengers per hour. Weight 1. So instead of again A to B to C, the pattern is now A to A to A then B to B, and then C, and continues. Gate A gets 3 passengers for everyone that gate C gets because it's 3 times more powerful. Pros of this algorithm: optimizes resource usage, perfect when you have different servers capacities, cause you need to know each server's capacity in advance and configure the weights correctly. And now for something completely different, the random algorithm. This one is beautifully simple. Just pick a checkpoint at random. It's literally like rolling a dice, get A, get B, or get C. Let the Fed decide. Passenger 1 goes to random selection, maybe get C. Passenger 2 does the random selection, maybe get A. And passenger 3, random selection goes to maybe get C or again get B. Completely unpredictable. To be honest, of this algorithm, extremely simple to implement, just one line of code. No tracking, no calculations, no memory needed. Works okay if all servers are identical and you have lots of traffic. But cons: unpredictable, you might randomly send 10 passengers in a row to gate A. Not optimal for the production system, and no intelligence whatsoever. Congratulations, you have just mastered load balancing, one of the most fundamental concepts in the modern computing. Let's review what you have now understand. Round robin, simple and fair distribution, perfect for identical servers. Least connection, dynamic load balancing, prevents server overloading. Least connection response time, performance optimization, fastest user experience. IP hash, session persistent, keeps user connected to the same server. Weighted round robin, different server capabilities, optimizes powerful hardware. And random, simple uniform distribution, works at massive scale. Right now, as we speak, Netflix is using their algorithm to stream to 230 millions of users. Amazon is load balancing millions of shopping requests. Google is distributing more than 8.5 billion searches per day. And your favorite apps are staying online because of the load balancing. You now understand the same technology that powers the biggest tech companies in the world. When you build your own application, you will know exactly how to handle thousands, millions, or even billions of requests. You're now ready to build your scalable system